about sort of the types of research that you've heard about. It's got to be a couple questions.
What's the potential, the redox potential of MXene phase when you use it as an anode?
Sorry?
The redox potential of MXene phase you're using right now for anode substitution?
Oh, is that insertion potential? Yes. This. Okay, so let me go one step back. So the insertion potential for the people who don't know what that is, the potential at which you get the highest capacity for the anode. In case of graphite, it has a very low insertion potential, so you need to go to very low voltages. That's why actually graphite have some issues with safety, because sometimes you start forming dendrites and catch fire. In case of MXene, actually, it is very interesting because we found that for each MXene has its own potential window. For example, vanadium works well at high voltages, higher than 1 volt. Niobium can give you high capacity at low voltages. Titanium is somewhere in between. So each MXene has its own active voltage.
So the one you got 36C?
This one has a little bit high potential, high potential insertion. So it's around, you get the highest capacity from 3 to 1 volt, which is useful because for safety issues. You may not get the highest energy density, but for safety it's better.
Other questions?
We have one from the online community.
Okay.
All right. It's a little long, so let me just try to read through this. The ROS created by mitochondria during stress has lipid peroxidation effects that lead to cell death through caspase activation and normal apoptosis. Sorry, I'm not a science person. But the lipid peroxidation is of the mitochondrial membrane, not the plasma membrane. How do you explain plasma membrane peroxidation? This is for Raha.
Sounds like it's from my sister. So she's right. One of the steps that I didn't show was that the mitochondrial damage can also lead to caspase activation. It also linked with calcium. This is all just one big picture that no one really understands completely. So yes, it does damage the membrane of the mitochondria, but some of the results that I have right now are showing that it does also lead to peroxidation of the lipid of the cell. So it might not be through a peroxidation mechanism, but it does lead to more damage. And why this is so important is because if we look at proxamer as a therapeutic tool, if the membrane portion is only happening at the very beginning, then there's a really small time window where we can use it to heal the cell. But if the membrane damage is happening continuously through other mechanisms, then there might be a larger time window where we can actually use this.
Other questions, comments? So what I'd like to do, I'm sorry, go ahead.
My question is, if you have generally a lot of data, a lot of properties from your experimentations, is there any way you can save all those data and you can access it later? When you're publishing a paper and all of a sudden somebody asks, how did you find this and where did you put this data? Will you be able to easily access that data? Any of those?
So this question is for
all of
Anybody?
them.
all of us.
I have the easy cheater answer. I don't have any data, I use other people's. What I do is run simulations to fit to real experiments from people who have a whole lot more money than me. And whenever possible, I just post the code online and make it open source. So anyone who's skeptical of my data or thinks it's cool, they can just make their own. So being able to put this stuff online means basically I'm trying to outsource some of the work and say, okay, I don't like my choice of parameters, go do better ones. Maybe you'll come up with something cool. As far as actually posting results of experiments, that's the cheater part. I don't have any, so I don't have to worry about it.
So right now, in terms of sharing data and results, we don't really, but I think that that's a really important thing going on at Drexel right now, how to share data, and I'm not sure, do you have an update on where that's gotten? How do we post that for other people to see?
Yeah, we can think about it, yeah, sure. And in fact, our libraries have a session database called IDEA, which is the institutional repository. It's an archive of all faculty and student projects. And as long as there are no intellectual property issue, we can be able to sell those.
For me, we wait to publish papers. Then all the data are already published, or all what I showed is already published, so it's accessible to everyone. But if you are talking about before publishing, sometimes, there is no certain way, as she said, that we share data before publishing at the moment. Maybe later.
So, for example, you may have presented some posters a couple of years ago, and out of those posters, you may have published a paper. And in your research paper, you are just mentioning it, but you are not reporting the data. So, in case if somebody wanted to know where would you find that poster, and if the poster is not saved, it's
Okay,
how
that's
they
it.
would find it.
Yeah, there is no certain way.
So I think there's a lot more efforts just to clue some people in with funding agencies, first of all, and second of all, with just sort of the scientific community and the capabilities that we have to not only better share data, but also better share our expertise. And so at Drexel, we're looking at both of these pieces. One is to make sure that we're compliant with data collection, storage, and sharing to the extent that we can, maybe 3 ways. The second is to have some sort of an exchange through the IDEA website at the library. And the third is to create a new expertise website or portal for all faculty at first, but I think you should all be aware of this, is that where you can really share your expertise and things like that through not only resumes, but be able to do keyword searching. Because I think in the conversations that we've had here, we really see that, Michael's work, crosses between people that are involved in energy and battery applications with people that are looking at atomistic properties of materials. Sam's work really is creating solutions for problems in a variety of fields, from economics to physics, I guess. And Raha's work is really connecting lots of interesting sort of mechanical and chemical systems and simulations, for example, with real life injuries, right? And so we're really looking at therapeutics. And so within these areas, there's so many people to consult and so many people that you might not know exist here at Drexel or at other places that you really have to start finding some expertise elsewhere. So how do you deal with something like that? Can you comment, Raja, on that?
So I think, I don't know if this is answering your question, but Philadelphia is a really great place to be if you want to tackle a really important question, because there are so many schools, and especially for biomedical hospitals and doctors that you can collaborate with. And Drexel, I've noticed, has been really good at collaboration, both in the university itself, so in my lab, you can walk down the hall if you need something, or you don't understand something, and there's someone to help you. But there's also lots of other schools that are willing to help you, so it's whatever you want.
Yeah, for us, we have some kind of annual meetings for materials scientists around Philadelphia, around actually Pennsylvania. This year it was here at Drexel. We had people from Raha Dastgheyb, Temple, Naguib coming here and start to present what they are working on. And from this you can get an idea. Okay, so this group at that school, they are experts in doing this experiments that I need for my work. So then I can go and approach them and start talking to them. And honestly, also a lot of collaboration is going through my advisors' network, because they have a very strong network. So that we can start to collaborate with other people that we know that they are experts in this part. And within Drexel as well, the same is happening.
Sam, I'm going to ask a slightly different question of you, and that is sort of like, now you have a PhD, tell us some people about the direction you're going in, how you're going to apply the knowledge that you've created and are utilizing.
Well, a whole lot of that, what is actually going to happen with that software is kind of up to, people here and anyone who stumbles across my website. What I'm doing professionally now is I'm working for a place called Susquehanna in Ballakimwood. I had mentioned that the math that I use is, finance borrowed it from physics a long time ago. I kind of borrowed it back. And so finance kind of came knocking and said hello. You were saying collaborating with other schools. There was a really, really big part of that to solve stochastic differential equations. And so I just emailed some people at work. And one of them used to work at Bell Labs, and I was like, physics, that's cool. So he was just giving me free tutoring from this, the guy who turns out was sort of legendary in his field. And then I got to audit a class there. So I was kind of self-teaching myself this stuff, but I had some high-powered help. And then what to do with the research I have now is it turns out real recently, David Wineland, who just won the Nobel Prize, did essentially a real version of one of my thought problems. And I written a simplified thing and said, well, imagine this silly toy experiment. And it turns out like people who were professionals went and really did this and got really similar results. So we're basically waiting for more experiments to come and either match my data or fail to match it. And then, I don't know, like once there's more qubit data, people might look at my models as a math curiosity that's useless, or it might turn out to be this really huge simplifying breakthrough.
Other questions, comments? So I just want to say, I mean, we're near the end of the hour and try to keep it on schedule. But I just want to say, I can't think of 3 better presentations of sort of what Drexel stands for. And in science, everywhere, so we're not just going to single out Drexel, but everywhere, we're really talking about more interdisciplinarity, more conversation. But here I'm just seeing and hearing this, basically sort of like really driving towards very significant outcomes with very advanced knowledge, with very advanced ideas, and from 3 really smart people. So I really, and some smart advisors, I guess, along the way, right? So what I really want to do is I really want to thank the 3 speakers and thank all of you for not only your attention, but for also pursuing in more senior footsteps, or maybe you guys are senior already, so they're following in your footsteps, but for sharing a lot of the knowledge that you have, and a lot of the experiences you have, and communications skills that you have in order to not only generate new data, but also to be able to communicate that data and those new discoveries to others. So thanks so much. And let's give them all a hand. So now for the 23rd version of Books Bagels. I'm sorry.
Brief overview.
Yours 15 and 47.